have your formulas given to you, all the chapter 2 formulas. So anything like, for example, the variance formula will be on there, the standard deviation formula, how to calculate a mean, how to calculate a weighted mean. Anything here that we're doing is going to be somewhere on that formula sheet and labeled for you. You just need to know what it means and how to use it. Okay, so no need to worry about memorizing that kind of stuff. All right, does anybody need a copy of this? Everybody have theirs? All right, so first one, this one was the ages of Supreme Court justices. So this is a population, because it didn't say it was a sample or a set of them. We've got 8 listed there, so that's our n value that we're going to use. The range is biggest minus smallest, so that's a quick little calculation. Mean wouldn't be too terrible here either. Add them all up and divide by how many there are. Speaking of adding and dividing, remember you're going to have a red calculator tomorrow. Okay, and then variance and standard deviation are kind of a 2-in-1 there at the bottom. As far as the table goes, your titles, you can label them with like X, deviation squared, or you can label them with the actual symbols if you want to. Either one's fine. But those are coming from our variance formula. So think of what you're seeing in this formula rather than like a normal formula we're used to in math where we're just plugging things into the formula. It's like a set of instructions. We take our x's and we subtract our mean from that, and then that's that deviation column. And then we square it, and that's the next column, deviation squared. And then that summation tells me to add up all those values. So this last value in that last column is what we need for that variance and standard deviation. And then if you want to check your work tomorrow as you're doing it, or Wednesday, whenever this one pops up, remember the deviations always add up to 0 if you're doing it correctly. So there's a lot of calculator work. I would say that's probably just the most common mistake when these problems come along. Beyond not understanding the formula, it's just a little calculator mistake, adding and subtracting, hitting a button wrong, something like that. So it's a good way to check, at least when you're partially through the problem. Okay, so once we add all those up, we divide by n, and here technically it's a capital N, it's our population, and then that gives us our variance. So our variance is that sigma squared. Then to get your standard deviation, we just take it one step further. If you look at the standard deviation formula on your sheet, it's just the square root of the variance formula. So that's really all we're doing in that last step, taking the square root of what we have for variance. If you have to round 3 decimal places is usually a good place to stick to for any of these problems. What questions do you have on this first one? Anything?
The M is mean, right?
So it's not an M, it's a mu. It's got an extra long tail there, but yes, it's the mean if it's population. And if it's sample, we'll see that in the next problem, we use an X bar instead. Okay, all good? Right. I'll put this on Polaris right at the end of our little chat here, so if you guys need to go back and fill anything in, you can. Okay. All right, so the one right below that, basically the same thing. You just have a sample instead. So because it's a sample, a couple things change. The notation changes a little bit. Instead of that mu, like I mentioned a second ago, it's going to be an X bar. And instead of a sigma, lowercase sigma, it's going to be an S for standard deviation and variance. But the steps are still the same. So our X is minus the mean or deviation, which if you add those up, it should be 0. I don't have that at the bottom there, but it adds up to 0. And then our deviation squared, our numbers got a little big here, but that's the number we need then in the formula. The only difference here is instead of an n in the denominator, it's going to be an n minus 1. So if I had 7 data values, we divide by 6. And then again, once you have variance, take the square root of the variance to get that standard deviation around the 3 decimal places if you need to. Any questions on this one? Okay. Let's flip through. Okay. Next on number 3, this is our big problem from section 2.5. If you look back at your notes, this was all of our quartiles, 5-number summary, determine if there's any outliers from those quartiles, box and whisker plot, and then percentage. So kind of walking through this problem, first of all, you want to count up how many data values you have. You have 26 data values in this problem. I went ahead and did the work of ordering it there on the side. It's definitely not something you need to write down, but you can. If there are 26 data values, split them in half. So 13 in the upper half, 13 in the lower half, and then 2 35s were right in the middle. So middle of 35 is 35. So that was my Q2, my median. From there then, I have 13 on the bottom and 13 on the top. So the 7th one in either direction gives me my first quartile and my third quartile. So that's 25 and 56. And then again, the min and the max are the lower and the upper number that we see in that list. Okay, that's our 5-number summary. From there, the inner quartile range is Q3 minus Q1. So 41. Nope, that doesn't look great. 31. Let's fix that. Oh, so something else is going to need fixed here too. Okay. Hold on. See, most common mistakes, basic math. Apparently I was having a hard time with that. All right, 31. That sounds better. Okay, so that's going to be a 31, and that's going to change all of these answers down here. Okay. These red ones will be fine. All right, so 1.5 times 31 gives me 46.5. All right, and we add that number to our third quartile, and we subtract it from our first quartile. Our third quartile was 56, so 56 plus 46.5 gives me 102.5. 25 minus 46.5 gives me negative 21.5. Remember, those are like fences, boundaries we're creating to see if there are any outliers. I don't think it looks like it changes any answers from my outliers. What did I have there? Oh, I might have some more outliers actually. 107 and 112 are also going to be outliers. I have a lot on that one. Box and whisker plot, number line, graph it above or below your number line. And then remember, in each section of this graph, we have 25% of our data. So how many flow below the third quartile? Third quartile would be the right side of your rectangle over here. So that's 3 sections of our box and whisker plot, so 75%. Questions on number 3? Okay. All right, next, make that a little bit wider for you. There we go. Okay, so this is the very last thing we did in 2.5, the z-scores. So the z-score can be written 2 ways depending on if it's a population or a sample. but this is the gist of it. You take your x value, you subtract your mean, you divide by the standard deviation. So you're doing that for 4 different x values here. Z-scores, we round usually to 2 decimal places. That's not super important right now, but when we get into the next few chapters where we start using it more, you're going to see the tables and charts we have only go up to 2 decimal places, so that's what we're going to stick with rounding. Okay, so all of our x values minus the mean divided by the standard deviation give us all of those decimals. And then remember we said something is an unusual data value if it's more than 2 standard deviations from the mean, because 2 standard deviations from our mean was that 97.5%. We were looking at the empirical rule. So it's the extra 2.5% on either end. So pretty small portion of our data that we're looking at if we're beyond 2 standard deviations. Okay, so B and C are both unusual, whether it's negative or positive, as long as it's more than 2 standard deviations out. Questions on Z-scores? Okay. All right, at the bottom. So it said the mean charge for electricity for a sample of households was 110 per month with a standard deviation of 1750 per month. Between what 2 values do 95% of the data lie? Assume we have a bell-shaped distribution. So the fact that they tell you it's a bell-shaped distribution is a pretty good hint as to what you're doing for this problem. It's the empirical rule. Grab my formulas here and see if that's on here. It is. So you don't have a picture of your bell curve on your formula sheet. But you do have the empirical rule itself, where it says 68% of the data is within 1 standard deviation, 95 is within 2 standard deviations, and that's what's important to know here. Whether you get the picture or not, 95% of the data is 2 standard deviations in either direction. So all we have to do is take our mean, 110, and add 2 standard deviations, that takes us to the right, and then subtract 2 standard deviations, and that takes us to the left. And then those are, again, kind of like the boundaries that are our 2 standard deviations in either direction. Okay. Questions on that one? Empirical rule. Okay, next up. Maybe. There it goes. Okay, 6 at the top, and then I have number 7 on the next page. I'll grab that in a minute. Okay, so this is another empirical rule problem. Again, the fact that they're telling you it's bell-shaped is a hint. So it says the mean charge for a satellite TV for a sample of households was $87.50 per month with a standard deviation of $14.50 per month. Estimate the percent of charges that are between 73 and 102. So all I did was took my mean and I started adding and subtracting my standard deviations until I got to those numbers, 73 and 102. And I only in this problem had to add and subtract it 1 time. Right? That doesn't seem right. Is it right? Oh yeah, that is right. We're okay. All right. Questioning myself after the other interquartile range mistake. All right. So all I had to do was add my 1450 once in either direction to get to the 102 and the 73. Because I only had to add it once, that tells me I'm 1 standard deviation in either direction. And according to the empirical rule, that's 68% of our data. If I had to add it twice in either direction, it would be 95% of my data. If I had to add it and subtract it 3 times, it would be 99.7% of my data. Okay, and again, if you need to, draw the bell curve and label it like we practiced in class, you could always do that here. Questions on 6? Okay, the rest of them I think I have on here. Yes, I do. All right, so number 7, there it is. Get a little bit bigger for you. There we go. Okay, so we have to do a couple things with this problem. We have to make a pie chart and then a Pareto chart. The pie chart's below, so we'll see that in a second. The Pareto chart, remember this is just like a histogram, sort of. It's more of a bar graph. Couple things you want to be careful of when you're making these pictures. Number 1, if you're making a Pareto chart, the bars do not touch, okay? Number 2, it has to be the highest category first. These bars are always in decreasing order, okay? So gold was the highest, platinum, multi-platinum, diamond, all the way down. And then just make sure any chart you guys are making, you're labeling. We're labeling the x-axis, we're labeling the y-axis. My x-axis here was just whatever types of certification for albums. And then we just labeled, you know, what each bar represents here as categories, more than numbers that we have to worry about. And the number of albums is what I have labeled on the side there. Okay, so not a whole lot of like calculations you need to do to create this graph. You're really just taking the values that you see in the chart, making a corresponding picture to go along with it. Now, the stuff you see in red here on the left, that's what you need to do to figure out how big each of your pieces of your pie need to be for your pie chart. So the first thing you need to do is you need to know the total frequency. So here the total, my n is 122 if I add up all those values. Then to calculate our relative frequency, F over N, that's a formula that you have on your sheets, relative frequency. It's just the frequency of each category divided by the N value. So for diamond, I just did 6 over 122. For multi-platinum, I did 26 over 122. And then we know that there are 360 degrees in a circle. So all we're doing is taking our relative frequency and multiplying by 360 then to get the degrees that we're going to see for each of our pie pieces. And those you can round to the nearest degree. If not exactly, you should be really close to 360 if you add that column up. So that's another good thing that you can kind of check when you're doing your work. All right, and then the pie chart at the bottom and look something like that. Your pie pieces don't have to be in exactly the same spot, but notice I labeled it again. I labeled each of the areas. They should be about the same size. Any questions on the Pareto chart or the pie chart? Number 8, if you're calculating grades or GPA, were 2 common examples that we saw in the notes. These are examples of weighted means, okay? So weighted means, again, formula is going to be on your paper. It's this guy right here. Okay, the numerator tells me multiply all your x's times w's and then add them up. So x's are, if we're talking about grades, your grades are your x's. I don't know if I can label that right now or not. I think I can label it on here. These are the x's. And then the category weights, obviously, are the w's. I used whole numbers for the grades just so I got a whole number answer at the end, but you can use decimals, you get a decimal answer at the end. Either way, it's going to be the same grade. So you can see the numerator, I'm taking each grade and multiplying it by the weight that it's worth and adding those all up. I would recommend writing it all out first before you try and type in the right calculator. And then for grades, really we don't have to use that denominator in most cases because it adds to 1, which this one it does add to 1 if we're talking about percentages. But let's see what the formula looks like. You could write it all out there. It's just the sum of the weights at the bottom. Questions on a weighted mean? Okay. All right. Next one's a biggie. I would say probably this problem and the standard deviation problem is going to probably take you the longest just because you've got these charts that you're going to have to fill out when you go through it. Again, math's not crazy here, just got to take your time with it. So for this one, if we're making our frequency distribution table, the first thing you want to do is figure out the size of our classes, our class width. So to do that, we do the range first, biggest minus smallest, that gave me 29. I divide by how many classes. In the instructions here, it said 5 classes, so we know to divide by 5. When you guys do your project, I think I tell you how many classes to use. Obviously, in real life, you can pick that number. So we divide by 5, and then whatever you get, you round up. Even if this was like 5.1, I still would have rounded this up to 6. You have to round up, so that ensures that when you create frequency distribution, all of your data values will fit. If you round down, you might not have enough numbers, and you might have to go back and start over again, which you don't want to do. Okay, then the next most common mistake here, besides the rounding, is how we create the class limits. The difference between where 2 classes start should be the class width. So I know I've got to start at 26 because that's my lowest value. So when I did this, I did all of these numbers in the first column first. Okay, so I started by 26 and just kept adding 6. Then wherever the next class starts, so 32, 1 unit before that is where the class previous ends. And then you can count on your fingers. You can see that there's 6 numbers in each of those classes, 26, 27, 28, 29, 30, 31. There's 6 numbers in that first class, and that's what we want, okay? Then, once you have the class limit set up, if you've done that correctly, everything else really should fall into place pretty nicely for you after that. So frequencies, we're just tallying up how many numbers in each group that we have. When you do it on the test, I highly encourage you to cross out things as you go, and then you can double check at the bottom here. It adds up to how many numbers you should have. So that's another good thing you want to kind of do before you get too far into it. Make sure you haven't forgotten anybody. So 20 here is the end value. Midpoints are just the middle of each class. Add up the ends and divide by 2. And again, those should increase by whatever your class width is. You can see all those are increasing by 6. Boundaries are just our classes extended by a half a unit in either direction. So a half a unit lower and a half a unit higher. Again, as you look down the columns, everything's increasing by 6. So check that as you go. That way, if one number's off, you can hopefully find it. Relative frequency is the same as what we did with the pie chart. Frequency divided by n. So my frequency column is that second column. N is 20. And that I didn't have to round any of those. Cumulative frequency is the frequency of that group plus all the ones before it. So the first frequency group was 5, the next one was 4, so that's why we jumped up to 9, 15, 18, 20. That last value should always be n in that last column. Questions on frequency distribution chart? Okay, so then at the bottom of this page, I believe you had to make some charts with that. Okay. Be very careful with the instructions on these. It's very specific. So this one was a relative frequency histogram, which means you were using percentages here, decimals, not whole numbers, okay? And that's what you label aside, relative frequency. At the bottom, average class size is what we're calculating with that data set represented. I got my little break in the graph because it didn't start at 0. And then it didn't say what to use here. I like to use, for mine, the boundaries because that gives me a label on each end of the bar, and it ensures that my bars touch, because where one ends is where the next begins. So that's what I labeled with. You could also have a correct answer there if you labeled with class midpoints, is the other way to do that. Okay, but I like boundaries for mine. And then just make sure your bars touch as you're going up. They go up to whatever the relative frequency was. On the side here, for part C then, it's an O-give graph. O-give means cumulative frequency. It's that last column in our chart. So we have to go up to 20. Again, I labeled with boundaries here because that will also ensure that it starts at 0, like it should with an O-give graph. We should always start on the axis. So 25.5 is half a unit before my first data value. So I know that's a 0 because there haven't been any data values in my set yet. And then just at every boundary, you include the next frequency again all the way up to this last value should be your end value of 20. Again, you could use midpoints for that. If you do use midpoints, you have to go back one midpoint from the first midpoint. So the first midpoint was like, I don't know what it was, 28.5. You have to go and start at 22.5 would be on the axes at 0. I like boundaries better though. I think it gives us a better graph. In letter B there, it could say just a frequency histogram. The only difference would be instead of relative frequency on the side, you just list frequency on the side and count up to, I don't know, 8 or whatever our highest frequency was. The bars would look the same. Any questions on either of our graphs? Okay. All right. On the back, then, a couple more things. So percentile. If you're in the 47th percentile, imagine percentiles, there's 100 people standing in line. 47th percentile means there are 47 people below you. Okay, so if I'm the 47th person in line, starts on that side of the room, ends on that side of the room, it's 47 people to your left. Okay, which means I am number 48 in line. So that helps maybe to get that second answer if you're not sure. Okay, you have to include yourself. Again, if we're thinking of those 100 people, so 47 people are below, that's what the percentile represents. But if you're number 48, what's the difference between that and 100? It's 52% or above you. Number 11 is just another weighted mean. Problems, it pretty much tells you you're finding a weighted mean because it says find the mean of the weights. So here, these are a little tricky because we have a group here. It's like a grouped mean, I guess, too. You might see that formula on your paper as well. But you don't have the actual data values themselves. We don't know if that first group, it's 118 or 123. We just know there's 3 of them. So when we had talked about this, if you have a large range and you don't have the actual data values, you use midpoints as x's. And then how many times each one occurs is like the weight, okay? So we multiply our x's times their frequencies, their weights, and then we divide by how many data values we know there are, which would be the sum of the frequencies, which would be 40 at the bottom here. Okay. So again, still using that formula at the top, you just have to know what to multiply. We have to be a little careful with our x because we don't have actual x values. Questions on number 11? Okay. And then I think, last but not least, this isn't going to be a problem. This is more for just like study purposes, I would say. Just knowing all your percentages. Again, the 68, the 95, the 99.7, those are all going to be on your empirical rule on your formula sheet for you. Okay, and between those two, that's going to be your test for tomorrow and Wednesday. It's split over 2 days just so you have enough time to do all the charts and stuff. That could be a little time consuming. Remember, the problems are not in the same order as they are on here, so you guys might want to make sure you know everything for tomorrow. As far as Polaris goes, I'm going to put these answers online for you right now, so you can go back and look at anything you need to. There's also some extra practice problems in Polaris. You guys have circuit training if you want it, so that's up to you. Circuit training is due tomorrow. If you're doing that, that's going to give you 2 bonus tickets on your test. And then 2-5 Math Excel is due tonight if you have not finished it with your quartiles. Okay, and then after that, we'll get a nice little break from Math Excel for about a week. You guys are going to be working on your project. Okay, questions for me before I do cell phone lotto and get stuff posted for you? No? Okay, you are on your own for the rest of the period. Let me know if you need anything.